Hello, this is lecture number 3 titled Measurement and Error. The essential question for this video is how do we measure variables, how do we record our data, and how do we estimate the error in our measurements? So like always, I'd encourage you to make sure you're really set up, ready to go. You've got your notebook, you got your pencil, and write down that essential question at the top of your notes. The first thing to consider whenever you're doing any kind of experiment or trying to take data on a variable is what tools are appropriate to use to do a variety of different measurements. If you wanted to measure the time variable, of course, the appropriate tools would be stopwatches or phones, or maybe a PhotoGate if you're in a science classroom. But for you guys, most of the time, probably your phones are going to work just fine. You should have an app on whatever phone you have. If you don't have a phone, your Chromebook probably has a timer app. So there's lots of ways to measure time at home. The second variable is mass. To measure mass, we need to have some sort of scale or perhaps a force probe or a balance that will tell you the mass of an object that you place on it. You've probably seen those before in science classes. The third variable from this unit is energy, and it turns out that's pretty much impossible to measure directly. It is an interesting variable that way. We're going to be talking more about that later on and why it's so tricky to measure directly. In general, the idea is that there's so many different kinds of energy that how can you have a single set of measurements that could capture the amount of solar energy and wind energy and sound energy. All those things are really different feeling from each other. So there's no specific tool that would let you measure energy. So when you're ready to take your data, you want to set up a data table like I've shown below. Some important features in every data table or things to include are column labels, right? So that's these things right here that just tell you what the data is. You want to make sure you don't just write down a bunch of numbers without making sure you tell what the numbers represent. The second thing is the unit. You'll notice that inside every column label, I put the units of the data that I was taking. So time is measured in days, mass is measured in kilograms. If you don't put the units on, we could be talking about days, weeks, hours, or seconds, and that makes a really big difference when we're trying to analyze our data. We also want enough data points to be able to see a trend. So we want to spread data over a variety of data points. So for example, in this case, I'm taking data over the course of 5 days so that I can start to see how the mass of whatever object I'm measuring is changing over time. In addition, we want to take repeated data in a single day, because that lets me estimate the amount of error in my measurements. This is particularly important if you think that it's hard to measure whatever it is, so that we can start to hone in on the actual value. When you take multiple pieces of data for the same value of one variable, it's often helpful to calculate the average value as well and include a separate column that has that average. Remember that the way you find average is you add up all the data and divide by the number of data points. So in this case, I would add 2.3 plus 2.1 plus 2.1, and then I divide by 3 because there are 3 data points, and that's going to give me my average mass on day 1, which is 2.2 kilograms. Once you have your data table, it's important to do what's called an error analysis or an uncertainty analysis. When you do an error analysis, you want to take each variable that you're measuring. So in that last example, we'd want to do one error analysis for the time and one error analysis for the mass. Then you want to consider specific things that might have caused those values to be different. You notice I took a bunch of mass data and they weren't all the same. So why did we get different values each time we tried to weigh the mass of whatever object? What makes them differ from the actual correct value? What is the actual correct value if I get 3 different readings when I try it 3 times on the scale? And the reason we want to think about this is because we want to eventually be able to estimate how uncertain or how much error there might be in our measurements. You know, if you stand on the scale and it says you're 150 pounds, are you exactly 150 pounds, or you might be 150.01 pounds or 149? Like, what is the error in our data? And this is going to be a really important understanding when we start to make graphs and come up with equations, is how far off from our data point could our actual data be. So let's run through a quick little error analysis because we'll be asking you to do this. Let's say we were trying to measure this adorable baby at the doctor. Doctors have this problem all the time. They want to know how big kids are and they have to measure them, but of course they're wiggly and cute and chubby and all sorts of challenges in measuring a wiggly baby. So if I was a doctor, I would think, well, there's lots of sources of error. For one, not every scale is perfect, right? And I think that's an error you guys tend to jump to. Scales are pretty good, but they're not perfect. So saying that the scale is not precise is a good source of error. Second source of error, the person is wiggly. If you've ever stood on a scale and jumped around or moved, you'll know that the scale value jumps around and moves as well. So that's important. The other thing is the person might have grown or shrunk a little bit since the measurement. Babies might pee in their diaper, or maybe their parents feed them right after they are weighed, and that's going to affect it as well. So you couldn't say for 100% confidence that the value that you got off the scale is really the true realistic weight of the baby. So let's say we weighed this baby 5 times, we got the following 5 values. The question is, how far off do we think we are? It's pretty useful to look at the range of this data in estimating your error. If every single data point said 7.1, I'd be pretty confident there's not a lot of error, but I've got data that ranges from 7.1 on the low end to 7.8 on the high end. So I would say something like a 0.7 kilogram error is a pretty reasonable amount of error to estimate. Okay, that's the end of this slideshow. So hopefully you know how to measure variables, how to record your data, and how to estimate the error in the measurements that you're taking. We're going to be using these skills for a variety of labs over the course of the year. So please take a few minutes and write a summary to remind yourself of some of the techniques and skills that you're going to be using. And when you're done, if you want a Calvin and Hobbes comic, so pause it and come back for the comic. Thanks.